Moving on to combustion problems for predicting products with chemical names. Number 5, we need to describe what happens in a combustion reaction. So in a combustion reaction, we usually have a hydrocarbon, which is a molecule or a compound that is made of carbon carbon and hydrogen, or carbon, hydrogen, and oxygen. So carbon, hydrogen, oxygen is what we're talking about when we talk about combustion reaction. And they must react with oxygen gas, which is just O2, usually by burning, to form carbon dioxide gas and water vapor. So the product, no matter what you react with, you are always reacting a hydrocarbon or a molecule made of carbon, hydrogen, and oxygen that reacts with oxygen gas. Their product is always going to be carbon dioxide and water. So for number 6, predicted products. For A, we have a propane, and that reacts with oxygen, and we will get carbon dioxide and water. That's going to be our products. It's always going to be our products for combustion reaction. Okay, so let's write the formula. Propane is a prop has a prefix means 3. So that means we have 3 carbon. And propane, that ending ane, that suffix, means that our number of hydrogen is twice of carbon plus 2. So 2 times 3 plus 2, which is 8. So it's going to be H8. Usually I'll always have some, type of hints there to help you guys out. For example, I will say tricarbon octahydrate, just to help you guys a little bit with the naming and writing formulas. Plus O2, and that will give you carbon dioxide, which is CO2, plus H2O. To balance this, we are going to list out our number of carbon, hydrogen, and oxygen on both sides. On the left side, we have 3 carbons, 8 hydrogens, and 2 oxygens. On the right side, we have 1 carbon, 2 hydrogens, and 2 plus 1 oxygen. So balancing our carbon first, we have 3 carbons on the left and 1 carbon on the right. So we need to multiply our right carbon dioxide by 3. And that will give us 3 carbons and 6 plus 1 oxygens. Next, we want to balance our number of hydrogens. So for hydrogen, we have 8 on the left, and we need 8 on the right as well. So 2 times 4 will give us 8. So we're going to multiply water by 4. It changes hydrogen to 8 and changes our number of oxygen to 4. And that will give us a total of 10 oxygens, which means when we come back to balance our number of oxygen, we need to multiply our right side or our left side by 5. So we're going to multiply O2 by 5, and that will give us 10 oxygens. And that is balanced. Moving on to the next problem, we have B, methane plus O2, where oxygen will also give you carbon dioxide and water. And our product, our reactants, methane, is going to be CH4 plus O2 yield CO2 So to balance this, again, we need to list out our number of carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. So number of carbon on the left, we have 1. Hydrogens, we have 4. And then oxygen, we have 2. For carbon, we have 1. Hydrogens, we have 2. And then oxygens, we have 2 plus 1. So carbon looks like right now is already balanced. Number of hydrogen, we need to multiply our right side by 2. So we have 4 hydrogens and 2 plus 4 oxygens, and that is a total of 6. So that means we need to multiply by our O2 on the left by 3. So we can get 6 oxygens. Alright, so for C, we have carbon dioxide and water for our products again. To balance this is a little bit longer. So we're going to write our formula first. We have C8H18 plus O2 yield CO2 plus water. Right. So to balance this, let's get our number of carbon, hydrogen, and oxygen labeled. Carbon we have 8, hydrogen we have 18, oxygen 2, 1, 2, 2 plus 1. Alright, so the balance for this problem is a little bit long, but it's doable. The first step, we always want to balance our number of carbon. So carbon, we need to multiply our carbon by 8. So on this side, I'm going to multiply this by 8. And that will give us 8 carbons and 16 oxygen. Next thing we want to do is balance our number of hydrogen. So for hydrogen, on the right side, we have 2. We need to get to 18. So we're going to multiply our water by 9. That will give us 18 hydrogens and 16 plus 9 oxygen. So then we realize a problem, that is we have the same number of carbon and hydrogen, but our oxygen on the left, we have an even number. And on this side, the number of oxygen really depends on this O2. So the problem is, it doesn't matter what coefficient you put in front of this O2, you will always get an even number. But on the right side, right now we have 25 oxygens. We have an odd number of oxygen. So it seems like it's really hard to get those two sides to be balanced without, add more oxygen to the right side. So what I'm going to do is I'm going to use this trick to make my number of oxygen even. So I'm going to take that molecule where we have an odd number of oxygen, which is H2O, because right now we have 9 oxygens from H2O. I'm going to double that. So I'm going to use 9 times 2. So that will change our number of water to 18, and it will also make this number of oxygen an even number. I'm going to change our number of water to 18. And that will change my number of hydrogen, which now it becomes 36, and this becomes 18. So it looks like we have to go back and fix our number of hydrogen. So on the left side, we have 18 hydrogens. We need to double that. So that will give us 16 carbon and 36 hydrogens. So it looks like we need to go back and fix our number of carbon again. Let's double our number of carbon by multiply 8 by 2, which will get 16. And that will give us 16 carbons and 32 oxygens. So right now our number of carbons is balanced, our number of hydrogens are also balanced. Now we have oxygen left. 32 plus 18, that is 50. can we multiply a whole number by 2 to get us to 50? Yes, so that will be 25. So if we multiply our O2 by 25, we will get a total of 50 oxygens. So that's how you balance C. The next one is also a little bit long. We have isopropyl alcohol plus oxygen, and that will give us carbon dioxide plus water because it's a combustion reaction. Writing our formula, we have C3H7OH plus O2 yield CO2 plus water. Label our carbon, hydrogen, and oxygen. On the left side, we have 3 carbons, 7 hydrogens, or actually 8 hydrogens. Forgot that there's one after the oxygen. So there's 8 hydrogens and 2 oxygen. Actually, 1 plus 2. We have 1 here and 2 here. So 1 plus 2. On the right side, we have 1 carbon and 2 hydrogens and 2 plus 1 oxygen. So to balance our carbon, we need to multiply CO2 by 3. That will give us 6 oxygens from CO2. And then balance our number of hydrogens, we need to multiply our H2O by 4. So that will give us 8 hydrogens and 6 plus 4 oxygens. So the problem right now is that on this side we have an odd number of oxygen, and on this side we have an even number of oxygen. So what we need to do, again, like the one before, we need to double our odd number to make it an even number. So right now, fortunately, we don't have anything in front of here, so we can just double that to make this 2. So now we need to change our number of carbon, hydrogen, and oxygen. So we have 6 carbons, we have 16 hydrogens, and we have 2 plus 2 oxygen. Since we changed the number of carbons on the left side, we need to change our number of carbon on the right side. Well, now we have 3. Well, 2 times 3 gives us 6. So which means instead of multiply CO2 by 3, we want to multiply CO2 by 6. That would give us 6 carbons and 12 oxygens. So looking at next, we need to balance our number of hydrogens, which on the left we have 16, on the right we have 8. That means we need to get our number of water, or number of hydrogens, to be 16. So 2 times 8 gives us 16. So let's multiply this by 8. And we should get 16 hydrogens plus 8 oxygens. So that's 20. Our number of carbon and hydrogens are balanced. All we have left is oxygen. So in order to get to 20 oxygens on the left side, right now we have 2 plus 2. So if we change this to 18, we will get 2 plus 18 equals to 20. So in order to get this to change to 18, we need to multiply this by 9. If we multiply our O2 by 9, we will get 18. And that gives us 20 oxygens. And that is balanced.